Okay, so let's take a look at some of the code that's in here. The first thing that we set up is a list of columns, and this is simply the list of all the columns in the data frame. And in fact, if you take a look, there's a Jupyter notebook in here that is actually a pretty nice example of using pandas for exploratory data analysis. And one of the steps that's in this notebook is to explore the names of the columns using the .columns method, which is how this list is produced, is simply from df.columns. And then the usual variables, except for this one. On line 14, my column is specified as corn. So as you guys have obviously figured out, you just switch that to any of the other columns in the list, and it displays that statistic instead. Now the pandas code, which is similar to what we've learned in the last few classes, we import pandas as PD. We read in the data frame using pd.readcsv, and we read in that CSV file from the assets folder, which is located inside of the repo. And then we filter on df my column. My column was specified earlier as corn, so when you switch it to something else, then you're just filtering down to whatever column you chose. But we also have an as type function which converts that column, which I believe is originally a string, into a float so that it can be color coded. Later on, Z is going to be used down here in Z data. Yeah, for color scale. Color scale is looking at Z for the range of colors that will be displayed in the map. And the way color scale works is you feed it any predefined color scale, and it will pick up a gradient using the numbers that you passed in the specified column. So if you have 10 colors and you have 100 values, then it will assign every color on a step of 1.1, 1.2, etc. The other thing you can do, by the way, is instead of specifying a predefined color scale, like this one, yellow, orange, red, you can actually just pass it two colors, say blue and red, and it will create a gradient all the way from extreme blue to extreme red. So it's another way to kind of get around if you don't know the name of the predefined color scale.
Where is that? Where's it picking that from? I mean, where's my line?
From line 17?
I know, but...
Oh, like that you're referring to line 17. So do I have a link to it in here? I don't have it immediately, but this would be, no, it would be Plotly, color scale. Should get a look at it here. Color scales in Python Plotly, what's color scale is available. This looks promising because I've been there before. So here's somebody who's listed in their forum. Let me make it a little bigger. And it looks like they have a link to those color scales, but somebody has summarized it here. But I will Slack this up so that you can take a look at it and get a better sense of that. What else is worth commenting on? So the way maps work in Plotly is to use the graph objects or go.choropleth method. Choropleth refers to a map that you can zoom in and zoom out on, as opposed to a static map. And the locations parameter will look for some predefined set of codes. State codes are used here because location mode is set to USA states. So it is expecting, since I specified location mode to be USA states, it's expecting to receive a set of locations that are the state abbreviations. VA for Virginia, DC for District of Columbia, etc. If you chose something else, if you chose, say, USA counties, then you would pass the 5-digit county FIPS code, and you would need to have a column for that in your data frame. And I believe in my repo I have a link to some more examples about that. Let me see here. Yeah, this one here, lots of other great examples similar to this one should lead us to the maps. Yep, so lots more about maps in Plotly Dash. I actually just stole one of their examples here about agriculture. You can see it's the same one that we were doing as a group. So that's about the size of it. Any other questions about this example? Things that you'd like to clear up? David, you got yours out? Cool. So let's go ahead and close that out and turn to repository 9, which I unlocked and slacked out at the end of last class. So go ahead and respond with emoji when you're ready in Jupyter Notebook. And in our code section, we've got 3 files: the user's dataset, the UFO dataset, and then a recap for you to work through the exercise again on your own. The way I like to split this up is 30 minutes for one, 30 minutes for two, and then 30 minutes for you to work through the recap on your own. Would anyone mind, given the interest of time, if I don't do a break today, but I just go straight till 8 o'clock, and then the last 30 minutes, which is your own time to do the individual work. If you need to take a break, you can do it at that time. People cool with that? Okay, then I'm going to do that. That will allow me to get through both of these notebooks. All right, so we're in Pandas, Exploratory Data Analysis 1. Under Data, we have a bunch of data sets, some of which we've used before, some of which we have not. We've got a README, which has a bunch of links to other resources that you can read about for learning about Pandas or exploratory data analysis generally. And under Code, we've got just these 2 notebooks, Users and UFO, so I'll start with number 1. And I am going to create a new notebook. I'm going to call this 01 Class Notes Users. And it looks like we've got 7, 8 people. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is anybody having trouble or need help opening it up? Cool. All right, so this is Exploratory Data Analysis, or EDA. Import Pandas as PD. Import OS from pathlib import path. And for good measure, let's go ahead and import NumPy as NP, but I don't think we use it in this notebook. Read in the users dataset. Okay, so where are we? Home is equal to path.current working directory. And where is the data would be equal to data directory is equal to path.joinPath home.parent and data. Let's go ahead and print that out so we can make sure it looks like what we would expect it to look like. So in mine, I've got it repo 09 and then the data folder. What's in there? os.list directory, datadir, and it looks like we've got those CSV files. Create path to our file. It's going to be equal to path join path, data deer, and user. Okay, why is this wrong? I'm going to try reading it in as follows. I'm going to call my data frame users, and I'm going to read it in as pd.read CSV path to file, and then I call up users, and that doesn't look quite right, does it? Can you think of what we saw in a previous class that might be missing here?
Piped limiter.
I'm sorry?
A piped limiter.
Pipe delimiter. So we could try that and call this separator is equal to pipe, and that worked really nicely. There is, by the way, another way to get at this. Users is equal to pd.read table path to file. Should get us the same results. But it's deprecated. Use read CSV instead and pass the separator as equal to tab or potentially pipe. Curious if that actually works. I think it does not. Let's see. Yeah, it does not. So it is in fact pipe. Okay. Everybody up to this point, you have the data nice and clean in front of you? Good. Now, what is this data set about? Well, apparently it's about users of a website or a software. I don't know the origin of the data set, but we have their user ID, how old they were, if they're male or female, what their job was, and then the zip code they live in. So some numeric fields, a couple of categorical fields, and then a categorical field that looks numeric, but in fact is not. Some zip codes are not really continuous. Okay. Preliminary examination steps. Kind of the first things you do when you start examining a data file are to get a sense of kind of the big picture. So I'd like to know what's my type. Type users, it's pandas data frame. What's the index? Users.index will tell me that I've got from 0 to 943 in steps of 1. It's possible to have steps of 2 or 3 or any number. Really anything can be an index. For example, I could even set the occupation to be the index. But here it's just a vanilla auto count. What's the method for having pandas display those column names? Just dot columns, exactly. Users, dot columns, with or without parentheses? Without, exactly. What is the data type of each column? For this one, you would want to use users.dtypes. And again, it'll give us the list of all the columns, but telling us that the first 2 are integer and the other 3 are string or object type. Now, what is a pandas data frame? It's a NumPy array, or it's really an array of NumPy arrays. That is to say, it's a kind of a matrix made up of lists. And you can see this if you take a look at users.values, 0. And it tells us right away the first row of data is an array whose values are 1, 24, M, technician, etc. That corresponds to what we saw up here, 1, 24, male, technician, etc. It looks kind of like an Excel spreadsheet when it's formatted by pandas. But in fact, it's simply like linear algebra. It's a matrix of individual one-line items, NumPy arrays. And that's why you can index it using the same indexing method we've seen with a lot of other Python objects. And you can also call up users index. And so the data frame has a set of values and it has an index. In this case, the index 2 corresponds to the number 2, but if we set some other column to be the index, then the second index might not actually be the number 2. It might be the word writer, for example. Let's call up a concise summary of the data frame using users.info. Again, will tell us each of the columns, how many rows it has that are non-null, and what is the object type. I don't actually use info a whole lot. I like to use describe a lot better. Describe numeric calls using users.describe. And this gives us for our two numeric columns, user ID and age, count, mean, standard deviation, min, max, etc. All right. And missing data, we took a look at this last time. Users.isNull.sum will tell us whether there's any missing data in any of our columns, and there is not. Always one of the first things you want to check. All right, take a look at individual columns. All right, so selecting one column, select one column, as we've seen before, is users gender dot tail. Shows us the last 5. And select two columns is the same thing, users, but with a double bracket, gender, and I think, what was the other one? Occupation. Sample. Keep in mind that you can also put this in double brackets and get formatted results. Anybody remember what's the reason for using the brackets here? The brackets mean two different things, the outer bracket and the inner bracket. What are they specifying? The outer bracket is a pandas method for a filter. So I'm telling pandas, take my data frame and filter it on whatever's inside these brackets. The second bracket indicates a list, which here has only one member, the word gender. That's why I don't actually have to have it in there. I can, for a single column, just call it like that, but it gives me the unformatted results. Down here, because I actually have two columns, it is necessary to have the double brackets. The outer brackets for the filter, the inner brackets for the list. What is the column type? And here I can call type users gender. And here it's telling me it's a series. But that's interesting because earlier when I called users.info, it told me that gender was an object type. So this is referring to two different things. This is when I call the info method, it is telling me that the data type inside the column is an integer or a string. But here, what I'm asking for is the type of the entire column, not the data inside of it, but what is this thing which I'm referring to as users gender, and it is a pandas series, kind of like a mini data frame or a one-column data frame. A series and a data frame have mostly the same properties and attributes, and many of the pandas functions are interchangeable on them. For example, up here I can call the dot tail or the dot head method on a data frame or on a series. And that will be true with a lot of other things as well. Just for example, to CSV, you can save a single pandas series to a CSV file if you wanted to. 7-11. And by the way, up here on my describe method, I forgot to mention that you can also describe non-numeric columns as follows. Users.describe, and here the parentheses allow us options. The option is to include columns of object type. And now it's giving me gender, occupation, and zip code, but not the numeric columns, or I can specify to include all, and it will give me both. Oh, but not in brackets. I wonder why one of them is in brackets and the other is not. I'm not really sure about that. Now it includes both numeric and non-numeric, but it gives NaN outputs for the times when the output is not applicable. Okay, so getting back to individual columns, a few column methods that we've seen previously. I can call users age, and then I can call the mean of that column. So this would tell me that the average age of my data frame is 34 years old. This might actually be a new section header. Mean of numeric columns. And actually, you can do a whole bunch of these, not just mean, but basically anything that's in the describe method, such as the median or the standard deviation or the minimum. That's the youngest person in the data set. The oldest person in the data set is 73 years old. And I believe the other one is count, if I remember correctly. Is that going to be in here? Yep. And the number of valid rows in that series. So all of these are methods that can be called on a numeric column. Methods for string non-numeric columns. So here I call gender, and I'd like to know what are the values in gender. I can call, as we've seen before, value counts. And this has a number of parameters, such as sort values or sort index. And this can also be specified as ascending is equal to false. Same with sort index. And you can also call value counts.values or value counts.index. So a whole bunch of different things you can do with value counts. And this will be useful later on when you start building a graphic. You don't actually want the full value counts. You only want the values, which is where you would use the .values method. You can also do that with numeric columns, but it's not really useful because you get a really long list of values. Much more useful to use the summary stats up here. Filtering and sorting columns. By the way, does anybody need me to go back and re-show some code? Cool.
I think pick those headings as quick as you do. The two pound signs. And
So I do pound signs. You can have up to, I believe, 6 is the smallest. And then I do escape, and that turned my cell blue. M changes it to markdown, shift return. So it's escape, M, shift, return. Okay. Create a series of Booleans. So we create young Boolean, or young bool, is equal to users age less than 20. And then if I print young bool, it's just going to be a whole bunch of falses and the occasional true. So not a whole lot of youngsters in this data set. Once I've created that filter, then I simply apply that filter to my data frame. Users bracket, remember brackets indicate a filter, young bool, and now where this young bool, let's put them by comparison. Actually, I think I want to do this the first 5. Where this was a single column, here it will filter the entire data frame on that set of Booleans. So it's calling back only the times when this was true, therefore skipping 0, 1, 2, 3, 4. The very first index that is younger than 20 is index 29. So that was a true, 35 was a true, 51 was a true, everything in between was a false. So filters are basically just applying a set of Booleans to the whole data frame. And of course, combine into a single step if you want to do that. You can do users, filter, and here I'm going to do users age less than 20 dot tail. So the filter is this portion here. I don't actually have to define it separately, and typically one does not. But as you get into the habit of reading pandas, the first time I saw this, I was like, I do not understand what I'm looking at. Why does it say users, and then it says users again, and then it has the sub-bracket? But after a while, you get used to kind of parsing this out, realizing this is its own statement, which can be treated independently or defined out in a separate cell, and then I can call it here. And in fact, in tonight's Plotly Dash app, that's exactly what I did, right? I defined my filter, my selected column elsewhere, and then I called that column in a repetitive manner in the figure that was displayed. You can select one column from the filtered results as follows. So just as I up here had users and I filtered it on users age less than 20, now I can call tail, or I can call head, or I can call a completely new column, occupation dot head, just as I would with an individual data frame. And this is similar to what we did earlier. df, sorry, Gannon McCullum's iPhone is trying to log into our classroom, probably from somewhere else in the building. Snuggle up against my wall here.